go ahead and get started. First and foremost, if you are a live student right now, you got a Unit 6 packet and this other sheet called the polyatomic ion sheet that has crazy things on it like perchlorate, and you're like, what is this? I mean, what is this noise right here? You guys can go ahead and take those and put them both in your binder and not worry about them at all until next week, okay? So they're just there for you. That way you don't, you have a lot of stuff you can follow along with when you're remote next week, okay? You cohort A students, you'll be getting a big packet from me Monday of next week. All right, anyways, your Unit 5 test is this Friday. It is 20 total questions, all on Schoology, and 58 total points. So it's actually a little bit smaller than the typical unit test. I think we're usually hanging out in the mid-60s, low 70s range. But it kind of makes sense. Unit 5 was only 3 weeks long. And all 3 of those weeks were 4-day weeks, so they're pretty short. So that's it for your test. It's going to go over the periodic table structure. So stuff like, hey, where are the transition metals? What does that mean? Where are the alkali metals? What group number are they? What do we know about the alkali metals? Stuff like that. Different trends, so like reactivity, atomic size, valence electrons, electron configurations. So if I'm like, oh, what's 3D4? You got to be able to tell me chromium. If I say chromium, you got to be able to tell me 3D4. And if I ask for the full electron configuration for chromium, you got to be able to do that too. And we'll do some practice of that here coming up. But the whole 1s2, 2s2, 2p6, 3s2, 4p, or 3p6, 4s2, 3d4, you got to be able to do that for chromium. Some of you guys are like, huh, whoo, all right. Yeah, I got that. And a pinch of history. When I say a pinch, I mean you should know Mendeleev. That's basically the only history of Unit 5. So remember, he's a weird Russian dude who he sort of looks like Rasputin, but he's like a little shorter. Anything on your review sheet is fair game. So that's going to be that last page, I think, in your Unit 5 packet. So that's all fair game. We're going to talk about the concept map. You will be able to use your own periodic table during the test on Friday. So your periodic table that, Mary's over here, it's colored beautifully. She's got her metals in green, metalloids in blue, non-metals in yellow. So you guys can use that if you want to. I will have blank copies. If you walk in here and you don't have your periodic table, I can give you a blank copy, but I would imagine most of you would prefer to use your own. Would be my guess. All right, and we're going to do some full electron configuration practice. So there's a couple of questions on your Unit 5 test this Friday where the formatting is a little goofy and you haven't done it before, so I actually want to practice as a class real quickly. So go ahead and get out your device. So again, you can use your phone for this if you want. And we're going to Schoology. So here we go. All right, I'm on my Schoology page. I'm going into week 20, since this is week 20. Today is Wednesday, last time I checked, so I'm going into the Wednesday folder. And you're going to go to this thing called Practice Electron Configuration Questions, no points. So what we're about to do, these aren't worth points at all. They'll have no impact on your grade. I just want to make sure you guys understand how to answer the questions so there's no formatting issues come Friday, okay? So if you go ahead and start your attempt, you can do this 5 times if you want. It'll look something like this. You're going to see this exact same question on Friday a couple of times. Now, this one in particular is for fluorine. You will see it for different elements, but this is exactly what it'll look like, okay? So I'm asking you guys to write the full electron configuration for fluorine. Why don't you guys go ahead and do that right now? So I'll put maybe 60 seconds on the clock. Do the full electron configuration for fluorine. You can write that on scrap paper. I don't really care. I'm not going to grade this or anything. But do the full electron configuration for fluorine, which is element 9. It's a little bit shorter one. You've done longer ones before. So go ahead and do that for me. And then I'm going to go through how to answer this question properly.
Yeah, I don't know. It probably won't work as well in here. It probably would, because you can't see it. Probably makes more sense on here.
Oh, yeah, that's a little goofy.
Okay, so this one's even not good.
Yeah, you'll definitely want to do it on your device then. Yep. Yeah.
If I'm already in, does it, like if I go out of it, will it matter? Not when it's actually...
If this was the test, that would be a problem, but this particular assignment, quote-unquote assignment, you have 5 attempts, so you should be fine if you, close out and go back in. Yep, for you remote folks, in case you didn't hear that, a lot of people are having some issues trying to do this on their phone. So come test it. You definitely want to be taking things on a Chromebook. Yeah. Anyways, so you're getting the electron configuration for fluorine, about 30 more seconds for that. Again, that's element number 9. It should be a relatively short one compared to other ones we've done. And let's see here. I'll bug somebody who's virtual here in a minute. Give me a second. So one of you virtual folks, I'm about to call on you for fluorine. Just whoever's popsicle stick I pull out of the jar first. Oh, let me see. Who's going to be the lucky winner? It won't be Barrett because he's here. It's not going to be Mooney either because she's here. Or Zach. Or Lexi. Good gracious. It will be Gozer, though. Hey, Gozer. Oh, nice, Faith. Can you tell me what the electron configuration for fluorine is?
1s2, 2s2, and 2p5.
You got it. Nice work. So 1s2, 2s2, 2p5. Again, if you're a little shaky on that, you'll have some opportunity to practice later today. But here's how you'd answer that. So you'll notice you have your SP and D on the far left. You have numbers 1 through 10 next to it. And you got NA after that. So I'll explain everything. So I'm going to go ahead. 1, S, 2, 2, S, 2, 2, P, 5. There we go. So that is the correct electron configuration for fluorine. Now, I know that you guys do not need the rest of these boxes, okay? And this is the correct answer here. But here's the thing. This computer will grade this, and all boxes have to be filled with something. Any blank box, even if you don't need them like these ones, will be marked wrong. Does that kind of make sense? Okay? So you need to actually tell the computer, hey, I don't need this box. So you have to grab NA, which stands for non-applicable, and you plop in all the empty boxes that you don't need. Okay? So it's a little cumbersome, but this is the best way that we figured to get you guys to actually write electron configurations. Uh-oh. Something like that. So you have to actually fill the blank boxes that you don't need with NAs. Okay? Now, there's several more practice problems here. So you got one for aluminum, you got one for potassium, and one for copper. When you hit submit, you can open it back up and see your grade, how you were graded. And if there are any issues with your formatting, or you put the wrong thing in the wrong box, or you forgot some NAs here and there, the grade will show you that. It'll show you where you missed points. So it'll have like a little red X. If you have nothing but green check marks, you should be good. I suggest you guys do all 4 of those sometime in the next couple of days and make sure you can get a perfect on this, just to guarantee that you're not going to have any formatting issues on Friday. Does that make sense? Okay. So again, you can take this whole quiz 5 times if you want to. It will never affect your score or your grade in any way. But there's that. So now, while we're here in the Wednesday folder, this is especially for those of you guys who are new students this semester. You'll notice in the Wednesday folder, there's this thing called participation points. Might as well go there now. Okay, participation points say 2 things. They say, how did you earn your participation points this week? You select A if you came to live class, so anyone who is currently listening to my voice at 12:55 p.m. on this Wednesday, you're currently in class. So live folks, remote folks. So if you just type in A and hit submit, you'll be getting 10 points. For anyone who's listening to this recording later on, you need to make sure you contact me personally and set something up. So I actually had a student email me over lunch like, hey, Mr. P, I have an MRI today. I can't make it to class. What do I need to do? We made arrangements. They're going to put B for their participation points and still get their 10 points. But you can't just put B because you didn't come to class. Like, you need to actually communicate with me. Does that make sense? Okay? Every now and then I'll have someone put B, and they didn't come to class or talk to me, and they'll get a 0 out of 10 for their participation points. So I always check. I literally check every week. So that's how that works. So if you go ahead and submit A for your participation points right now, you folks who are live, you'll get your 10 points. So you might as well do that right now. And then once you're done with that, we're back here to the smartboard. All right. So go ahead and take a look at your concept maps, which I believe are the second to last page, right towards the end of your Unit 5 packet. So I'm just going to highlight a few things. This is a little bit more detailed version of what's going to be on your test, okay? And this is where I'll call in a few people just to see how we're doing. So one of the things you need to know is the organization of the periodic table. So what are the names of specific groups? Alkali metals, halogens, noble gases, transition metals. Their general characteristics. Where are metals? Where are metalloids? Where are nonmetals? All that good stuff as well. So, for example, let's see here. No, he's here in person. Mr. Clark, can you hear me? Not sure. He might not be here. Okay. All right. What about, hey, Ian, can you hear me? Yes. Hey, Ian, if I ask you for a characteristic or two of metals, tell me one or two things that you know about metals. Of metals. What are some common characteristics of metals? Good conductor and shiny. Absolutely, Ian. This doesn't mean that literally every metal ever is shiny, but most metals are shiny. This would be similar to, let's see here. How many of you in this class, by show of hands, will be 16 before the end of the school year? How many of you will be 16 before the end of the school year? Only half of you? Most of you guys are going to be 15 by the end of the school year?
Oh, like that aren't already?
All right, by May 30th, how many of you guys will be 16 on May 30th this year? So like you're already 16 or you'll be 16 by then. Okay, most of you, right? All right. So I would say most sophomores are 16 by the end of sophomore year. That doesn't mean literally all sophomores are 16, but that means most of them are. Same way, most metals are shiny. Doesn't mean all of them are, but most of them are. Okay, most metals are good conductors. Not all, but most. So nice work there. Ian, let's see here. Hey, Cece, talk to me about nonmetals. What do you know about nonmetals?
They're usually brittle and dull.
Yep, brittle and dull. So if you try and bend them, they won't really bend. They'll just snap. So for example, what do I have up here that's snappable? Oh, I don't know. Oh, I could break that plant, but I don't want to do that. What if I break? Oh, here you go. This piece of wood, a popsicle stick, is a non-metal. I try and bend. That's it. Try and bend it, and it just breaks right there. Whereas if I take a paper clip and try and bend that, look, it's nice and bent, but at the same time, it's still in one piece. That's because paper clips are metal, and they can sort of stay intact. Boom. There we go. Okay, not bad. Oh, let's see here. Who do I want to bug? Hey, Mr. Spade. Tell me one section of the periodic table. It could be any group, any section, and one characteristic about it. So anything.
Noble gases.
Noble gases, great. Tell me something about them.
They're inert.
They're inert. What does that word mean?
Means they don't really react.
They don't react with anything. Great. Okay, so you need to know that kind of stuff about your noble gases, your alkali metals, your halogens, all that stuff, okay? And you should be able to identify where they are on the actual periodic table. So if I'm like, Justin, where are the noble gases? You would say the far right, aka group A. Okay? So he's like, yeah, that's exactly what I would have said. All right. Again, history stuff. Oh, Mendeleev. Let me pick on somebody. You're here. Hey, Colin, you there? Not sure if he's here or not. There was. Now there's a... Oh, is that Colin?
Yeah.
There we go. Hey, Colin, what's the name of the one guy who came up with the periodic table? What's that guy's name again?
Starts with an M, right?
It does. How fast can you Google that?
It's like Mendel something, right?
Yeah, Mendeleev. And honestly, as long as you could recognize that name if you saw it, you're in good shape. I don't really care too much about the pronunciation. Colin, what exactly, how did he arrange the periodic table? I'm like blanking.
What did you say you missed that out, right?
How did Mendeleev arrange the periodic table? How did he do that?
With the atomic number.
Close. That's how we arrange it today. Do you remember how he arranged it?
Yeah.
Somebody help him out. Who knows how he arranged it? Barrett? Yeah, atomic mass. Yep. Mendeleev organized the periodic table by atomic mass. Today we arrange it by atomic number. Nice work. Now, when you arrange elements in order of atomic mass versus atomic number, 95% of the time it's the same order. Okay? But there's a rare exception every now and then. For example, argon element 18 has a mass of 39.9. Potassium element 19 has a mass of 39.0. So even though potassium has one more proton, it actually has a little bit smaller mass than argon. So they're not always the exact same order, but they're pretty close. The reason why argon is on the right and not the left is because argon is really similar to the other noble gases, like neon and like krypton, above and below it. Not bad, not bad. Oh, let's see here. So that's really the only history you need to know, right there. Basically everything we just said. Electron configurations. So you need to know where your SP and D blocks are. You need to know that the D block starts with 3D, not 4D, that kind of stuff. Plenty of time for practice for that coming up here soon. Trends. Let me talk about the two most confusing trends real quick. Okay, atomic radius, okay, the size of something. As you go down rows, what are you adding as you go down a row? Energy level, and atoms are getting what? Bigger, that's right. Now, as you go from left to right on the periodic table, the energy levels stay the same, but you're adding protons, so atoms get what as you go to the right? A little bit smaller, okay? So that's atomic size. Now, be careful. Atomic mass and atomic size are not quite the same thing. Size is talking about the actual space an atom takes up, okay? Whereas mass is like you put it on a scale, what would the number be? So for example, if you look at sodium and magnesium, elements 11 and 12, sodium is a little bit bigger than magnesium because it has one less proton and the electrons aren't squeezed quite as tightly. But at the same time, magnesium has a little bit higher mass than sodium. Do you guys see that? Okay. So just be careful. Mass and size are not quite the same thing, so watch out for that. The other trend is reactivity. So remember, metals get more reactive as you go down the group. Non-metals get more reactive as you go up the group. So francium, the bottom of the alkali metals, is the most reactive metal. Fluorine, the top of the halogens, which is a non-metal family, is the most reactive. And again, the noble gases, in terms of reactivity, they're what are they? They don't react. They're inert. There you go. There you go. Not bad. Another question or two. Hey, Tanner. Tell me something about valence electrons. Like, what are those? Like, what do they do? What's the deal with those?
I know it's the period number, but what? Oh, isn't it the amount of electrons that can be doubled? It's a really bad explanation. If there's two valence electrons, then 2 electrons can fit in each one, but they don't.
We're sort of there. We're sort of there. We need a little polishing. Let's see if I can get someone to help you out. Who can I get? Hey, Meg, can you tell me anything you know about valence electrons?
They like go with the group numbers on the periodic table.
Yep, the group number. So if you're in group 3, you have 3 valence electrons, so that's that column number. Do you know anything else there, Meg?
Are they like the electrons of the outer part of the atom?
That's right, yep. So they're outermost electrons. So if an atom has 4 energy levels, the valence electrons by definition will be in the 4th energy level. If it only has 3 energy levels, it'll be in the 3rd energy level. Not bad, not bad. Can anyone tell me what valence electrons are even used for? Like, what do they do? Yeah, they're used in bonding. The only electrons used in bonding, or like any kind of reaction, is because of the valence electrons. So if you're like, oh, why'd that catch on fire? The short answer is the valence electrons. Now, that's not really full explanation, but the valence electrons are sort of the reason behind everything in chemistry, in a way. So there's that. Not bad. All right, not bad. Here's what I'm looking for from folks. This is your Unit 5 review sheet. This is the last page. There's a lot of great practice in there. Some problems that I definitely suggest you guys do, not because they're the most important in terms of like points on your test, but because they're the most missed, would be, I would definitely strongly recommend doing it's on the back here, I think. Where is that one? Number 13. I definitely recommend doing number 13. Again, this isn't the most important question on the review sheet, but it's probably the most missed, I think. So it's asking you to compare which of those 2 atoms is more reactive, and that's because reactivity is probably the most difficult trend for people. So here's what I want. This answer key's in the Wednesday folder, okay? So you can kind of do a couple problems, check a couple, that kind of thing. My live folks, I want you guys cooking on this, and I'll come check in with you guys personally here in a minute. Remote folks, so please keep in mind, you don't come to class tomorrow because it's a lab day. So this is the last time you're going to see me before Friday's test. So I'm going to check in with each one of you guys. Please ask me any questions that you have. And I'm also going to see if you guys have finished your lecture questions from yesterday, and we'll talk about that. So live folks, get cooking. I'll come check in here soon. Remote folks, I'm coming for each one of you guys right now.